Now we are dealing with functions, one of the last topics we want to present to you, even though there are many others to learn how to program, such as classes. We have taken the most significant notions to learn how to program, which can be found in virtually all program languages. A function makes it possible to better think the code, making it more understandable. They are called by name and sometimes parameters are passed. They can be executed and are a list of instructions, and sometimes they also return values. A function, for example, is the one we have used up to now, block, brick with coordinates x, y, z. We've used it but we've never seen it, and so now let's see how a function is created and used. We will see, first of all, the syntax, that is how it is declared. The syntax of the function is as follows: def, this is a keyword. After def we have the name of the function. In round brackets you put the parameters, separated by commas, and then we have the 2 points. In the new line, after the function declaration, always indented to the right and aligned with each other, there are the commands or a command. After the commands, at the end, if necessary, we have the keyword returned followed by the result. This is useful in case the function returns a value after a calculation. The name of the function must be meaningful, because when we call it we must remember something of what it does. Now we will see various types of combination of what I have said and how it is used. In the editor example we have the function name square. We can pass various parameters to the square. In the example we put only the coordinates, but we could also pass the size and the material with which we want to be done. Inside we perform true for command, which range is always the same, and in this way we move on 2 sides, once horizontally and once vertically. As usual, we use the block function call to construct the square figure. At the end of the definition of the function we have the call with square x, y, z. The block we have in the function moves on the x with I and on the z with j, because it is a square base level of the lawn. If we wanted to see it at the top we would move on the y and not on the z. Let's try to execute it. This square of size 5 and of white material. I call the square function with the generic coordinates x, y, z, and we see that it comes out. Here this is our square, so we repeat, def is the keyword that introduces the square function, that is the name of the function. In the case of parentheses separated by commas we have the coordinates that are the parameters. We have the 2 for loops that cycle on the size of the square. Let's see the block function with the material with the coordinates x, y, z. This is the definition. If we want to construct a square we must make the function call that is square with its parameters. The parameters must be exactly as they are declared in the function in the same order. If we put generic x, y, z, it is the ones chosen with the cursor. Now let's see a function without parameters. The definition is standard edef, name, central column, function, round brackets followed by the colon. We have no parameters within the round brackets. We see that in the definition of the central column, we want to construct a column in the point of origin, that is, of 0 coordinates. I established that I wanted high 6 and white material. Let's do a for loop. At the end we do the function call. We called the function, central column, because we chose to put a column in the center point. Try to do it by checking that nothing is missing. Now let's see the functions that return a result that is a classic function of programming, the sum. So we always have def, function name, in this case, sum, round brackets with 2 parameters a and b. Inside we have a variable c to which we assign the sum of a plus b, and finally we make a return of the value c. If we call the sum function of 5 and 4 and we print the result, we see that it prints 9. Let's do an exercise in which we build the pillar function. In practice we define the pillar function, we pass the parameters. Besides the coordinates, there will also be the material and height. The command inside will be a for loop that obviously serves to construct the pillar, always using the block function. Always remember to put the function call to try running it. Remember to keep the list of parameters in the order in which you defined them. Good job!